Hi, everyone. Welcome to Riot's Lunch and Learn series, the place where we feature all of Riot's partners. My name is Caroline Griffin. I am Riot's Director of Operations, and I'm super excited to have one of Riot's newest partners, SingleStore, with us today. We actually have David, Senior Manager of Education Delivery, here to talk to us about architecture for developers, a primer on distributed SQL systems. Before we get started, just a couple of quick reminders. Please do keep yourself muted throughout the presentation. If you have any questions, please drop those in the chat, and there will be a spot at the end where David will do some pretty interactive stuff, so you'll be able to unmute yourselves then. The second reminder is that this session is being recorded. It will be posted to Riot's YouTube channel and then shared out via the Meetup group where you signed up for this event. And those are all of the reminders I have for you. Thanks again for being with us today. Without further ado, I will hand it over to David.
Thanks so much, Caroline, and thanks everyone for joining us today. We're really excited for this Lunch and Learn and excited to partner with you from the whole team at SingleStore. Just some setup for today's Lunch and Learn. At any time, you're welcome to share any questions you have in the chat. We'll have those available throughout the session, so feel free to share any comments there. Really excited to answer your questions you might have about the product, including SQL and its distributed nature. Beyond that, we'll be having some interactive features. We'll be doing some live polling as well as a demo of the product where you'll be able to dive in deep as well to get further acquainted with distributed SQL. So without further ado, I'll get us started here and look forward to taking you on the journey for architecture for developers, a primer on distributed SQL systems. Today, we're going to focus on a few core parts as you're learning about SingleStore and its product ecosystem for data-intensive apps. We'll start with an architecture overview. We'll dive into aggregators, leaf nodes, and partitions, and finish up with shard keys for distributed technology. A little bit about SingleStore before we get started. There's a lot of ways to learn about the product. We have everything from our documentation, engaging with peers on the forums, checking out YouTube, our training, and our support center. So today we're doing our live interactive webinar. This means for everyone who's joining today's session, you're going to get $500 in free credits today to work with SingleStore on the cloud with our SingleStore managed service offering. You're welcome to get set up as we're starting this session by going to singlestore.com/managed service trial, where you can sign up, register with your account, and you'll be able to work with our product on the cloud for the first time for free. So feel free to get that set up as we dive into the session. And a little bit more about SingleStore. Our product is about building and scaling data-intensive applications. As we've seen in the last decade, data is only continuing to grow in size and complexity. And whether you're building analytics, dashboards, or applications, the speed is needed to build real-time insights, real-time results, and real-time capabilities for your products, your applications, and/or your clients. And that's where SingleStore comes in. It provides the real-time offerings both as you scale the amount of the size of the system and the size of the users. Our results can be in near real time with sub-millisecond latency. It's a very exciting product, and we brought out a lot of new features in summer 2021. Today, SingleStore is known as the single database for data-intensive applications. And SingleStore has its latest release, 7.5, which came out this summer in July 2021, which provides some exciting features to scale any product that you're building on the cloud. Today, SingleStore is available on all the cloud providers, including AWS, GCP, and Azure, and open source marketplaces such as Red Hat. We're going to dive into today's topic covering about architecture. Our first section of the topic is going to focus on aggregators, leaf nodes, and partitions. What are these terms and why are they important to distributed SQL systems? Let's start off with aggregators. Many of you are today joining this webinar from your computer. And in fact, your computer is itself an aggregator. It is a system that can process requests. When you think about those requests scaling up for analytics and applications, at the heart of those systems, there are aggregators. And the aggregators are the command planes. They will manage the entire request from the end-to-end lifecycle, from configuring your storage and compute through the database design and the distribution of data among the system. At SingleStore, we have two types of aggregators to manage these processes. The master aggregator is that command plane that stores all the metadata and the configuration across the entire system. And there can be child aggregators to help distribute or load balance those requests across the system. Beyond having aggregators in a distributed system, there are also nodes. Nodes are at the heart of storage and compute. They store the databases and the tables that make up those databases together. What the nodes are is they are the workhorses of a cluster. And for a SingleStore managed service, those nodes, you can think of them as commodity hardware like Linux AMI machines that not only house data, but also run the results for a request. In this visualization here, you can see a requester. Perhaps it's yourself on your computer. Maybe you're running through a MySQL wire protocol compliant API or an HTTP API. You're sending that request to the cluster. And then that request is being shared through this SQL interpreter into an aggregator. And depending on the nature of that request, it is distributed among different nodes. Those nodes are called leaf nodes. These are the nodes that process not only the storage, but also the compute. And after that request is processed, the results are sent back up to the aggregators where that result is tallied up. And once it's confirmed, it's sent back to the requester, call it that dashboard, that application, or that CLI endpoint to display the results from the request. Now, thinking about this at a more granular level, on SingleStore, the clusters do have some requirements. And these are the same requirements whether you're building your data-intensive applications on our cloud, the managed service, or on-premise with the self-managed product. All these clusters will require a master aggregator to run your DDL and DML commands. They'll have one or more child aggregators that support DML and DDL forwarding. Leaf nodes, where you can have at least one of these to store and scale the compute of your requests and scale as much as you need so you can have in real time results for your mission critical applications. What do leaf nodes look like on SingleStore? Here's an example of two of them. What you see here on this demonstration are two nodes, these leaf nodes. Each have partitions. In this case, there's 8 partitions in each node. All those partitions are supporting with both storage and compute. And in this case, we see there's an even distribution of data among those nodes. That even or unique distribution, which means that there's a high cardinality or high uniqueness occurring on these nodes, was set up by design when the schemas were created for the tables. And that is the magic at work for SingleStore. For our distributed engine is building tables from the ground up so you have even distributions and fast compute among any requests that you have. Now, that's a lot of knowledge that we just unpacked here. As you're getting started on learning about distributed systems and how they move among these different nodes and how they're shared among these partitions, let's now take a mastery look with a knowledge check on this architecture section. This one will be interactive. So we have a poll here. This is running through Poll Everywhere. There are a couple ways that you can live participate in this poll. You could either go directly to pollev.com/DavidY075, or you can text DavidY075 to 22333 and provide your selective choices. So take a moment here. This question is on what does the master aggregator do in a single store cluster? For this question, there could be more than one correct response, so feel free to participate directly from one of those two options. All right, I see a couple of results are coming in. We can show those responses live here to see how people are participating. Again, there could be more than one correct answer. So I see a few participants have chosen option A and B, less choices on option C and D. Let's give you another 30 seconds to participate on this question. All right, so thinking about this question, what does the master aggregator or the command center do for a single store cluster? Well, there's a few things that it could do, and I do see that we've had more than one response on each answer selection. And that's because, in fact, there's more than one correct option for this question. First, the master aggregator, yes, option A is correct. It does receive queries from the requester, and it distributes that work to those leaf nodes. Second, what else does it do? We mentioned that towards the end of the previous section that it will combine results that are returned from the leaf nodes. That's option number D. So D is also correct. Also, option C will be correct. It will return query results to the requester. That requester could be you. It could be a dashboard. It could be a certain tool that you're looking at as well. And as lots of responses are coming in, although option B as in Bravo was the least selected choice, the master aggregator is the central command plane, which means it also stores the cluster metadata. So in this question, all four options are correct. Appreciate your willingness to respond in great selections there. Okay, let's reset the plane. We're going to now go for our second question here. The second question for this knowledge check is, what does the leaf nodes do in a single store cluster? You can use the same link that we checked out before, or text as well your answer selections, and there could be more than one correct choice. I'll give everyone another 30 seconds here. Let's see the responses coming through. I'm going to reveal those right now. All right, so we got some different responses here in this question. Looks like no one fell for option B as in Bravo. This is an incorrect answer because option B as in Bravo, the return query results to requester, that is the job of the master aggregator. So B as in Bravo is incorrect. What else might be incorrect here? Option A as in alpha. So in fact, what we have here is that combining results of the queries, that is not correct. In fact, that's done by the aggregators. So A is also incorrect. So in fact, I think our audience, you got it right here. In fact, the two answers that are correct for this question are option C, the third choice, and option D, the fourth. Primarily that these leaf nodes will store the data. They are the data centers, if you will, where all the databases are broken down by partition, by a table format, so you can distribute those workloads. And then secondly, these leaf nodes will execute the queries. They will actually solve for the requests, whichever SQL statements, user-defined functions that you create will be solved for based on the data that's stored in those partitions, or also broadcast or repartitioned across the distributed system to ensure you get blazing fast results. All right, great participation there as well on this knowledge check. As a reminder, as we go through any of these topics, feel free to share questions you may have in the chat. Chances are when you have a question, other participants may have that one as well. So whether you are just getting started or you're a seasoned expert with distributed systems, we're glad to give you some insights on your learning journey. This will take us now into our second section for today's Lunch and Learn on sharding and shard keys to help you understand more about how the data is distributed and broken down among the different partitions on the leaf nodes. After we go through this section, we're going to dive in together into a hands-on lab. So recall that link I shared at the start of the session on the managed service trial. Feel free, if you haven't yet, I'll share that link in the Zoom again, to create your account and sign in. We'll be launching our own cloud clusters together in just a few minutes. Okay, let's cover now on sharding and shard keys. So it was mentioned that you'll have a system like this, where you have an aggregator or aggregators, and they'll take a request from you. Maybe you're building a dashboard in Tableau or Power BI, and you have a request, or you have an application that's running in the web browser, and you're looking to get a result there. So those requests will be routed from the aggregator and distributed into the leaf nodes. In this scenario, we have 2 leaf nodes with 8 partitions on each, which means we have 16 partitions, which means that any table, you're distributing it into 16 pieces. By doing that, you can rationalize that the cost of compute will be 1/16 the time as normally doing a process in one partition or on one process. And this is the benefit of sharding, of distributed SQL engines. And with choosing your shard key wisely, you can create this even distribution where you're having a high cardinality or a high uniqueness among that shard key, which is essential for distributing the data. The great thing about SingleStore is it is a smart engine, which means even if you choose not to include a shard key, SingleStore will choose the smartest one it predicts for you to facilitate the distributed compute. In the lab we'll do today, we're going to pick a shard key together to show you how simple it is to create your own data structure known as a column store with a shard key. Now, the importance of choosing shard keys is as follows. They are here to evenly, or as close as possible, distribute your data among the different partitions. In the ideal world, that is the best case scenario, though every table has a different schema design and a different distribution of data, which means there may be chances that you'll have distributions like on this demonstration, where some of your partitions will house more data from the table than other partitions. And what will that result in? Well, you'll still have successful requests. You'll get the results. They'll be returned back to the requester. Though looking at partitions, if I look here on this first partition and this second partition, we see the difference here in distribution. Which partition will most likely give a result quicker to the requester? Well, you might be tempted to say partition number 2 because we'll get the job done first. But the catch is the aggregator will be listening until all of the partitions finish their work before routing results back to the requester. So your system is only as fast as your slowest partition. Or in other words, the system is only as fast as the partition that houses the most amount of data. And so you're looking to optimize that with as even of a distribution as possible. Another way we can think about sharding at SingleStore is it works for any type of workload. So today, SingleStore is the database for data-intensive applications, and it supports HTAP workloads. These are hybrid transactional and analytical workloads. When you're working with a system, let's say here we have data, these zeros and ones, they're being inputted from the requester. They're going into, let's call it this cluster, this SingleStore managed service system. And that request is first checked in through some algorithms. So if you're running a column store structure, a hash algorithm is taking a look at the data and identifying specific pointer references where the data exists to further accelerate the system. The shard key as well will be accelerating your system by distributing the data among these different leaf nodes. Here there's 4 leaf nodes shown with a total of 32 database partitions where those tables are split. So sharding, in fact, is to your benefit. It's not the only technique. There are a variety of techniques that our query engine and query optimization team at SingleStore have built to provide you very fast results for your data-intensive applications. Let's look at one more scenario about shard keys where you can get practical with a schema design to see when we've chosen a best-in-class shard key and a not-so-best-in-class. In this scenario here, the order ID is chosen as the shard key. We can see how for our 16 data points, they're all unique. That means there's high cardinality for this data. So when they're distributed among the different partitions, these 16, it's an even distribution, which means when you share across a request, there's a good likelihood that the results are going to be processed in the same amount of time, and you'll get the best performance for your request. An alternative scenario is this one, where customer ID is chosen as your shard key. As you can see in the column, there is some repetition of the data elements, such as the numbers 20, 12, 9, 2, and 1, and that results in larger amounts of data being stored in the tables of the database in those partitions. Now, it doesn't only mean that, well, the numbers 12, 4, 2, 1, and 9 house more data, but in fact, some of the partitions like 0, 3, 5, 8, 11, and 15 are unused. They're sitting by idly when you're performing a request. It's a waste of compute. You want to maximize the usage of your compute, and that's the differentiator on why selecting the best-in-class shard key is important to get the fastest results you can for your request. Now, thinking about the best practices for choosing shard keys, there's a few goals to think about here that we'll look at in summary. The first one as a goal is to evenly distribute your partitions with little skew. You're trying to minimize data skew so that your queries will use all the partitions. How you can think about that is choosing a shard key that has high cardinality or uniqueness. In computer science, we think about this primary key or a unique column. And secondly, you might have a goal to have partitions that gather records that are common on a particular field. Perhaps you're running where clauses, group by clauses, order by clauses, certain aggregation functions that use this common field over and over again. Perhaps it's part of your top 10 queries that you're running used for your mission critical workloads. In that scenario, you'll want to consider that shard key could match the field that you're doing these intensive applications, such as group bys, where bys, joining, and so forth. As you've seen in this section, shard keys are very important in distributed SQL systems. And at SingleStore, it's one of the key elements, in fact, the shard key, to build robust data-intensive applications. All right, we're going to get ready for our next section where we're going to dive in together into a lab where we're going to create our own table on SingleStore Managed Service. We're going to all spin up a cluster together. In order to do that, you'll be encouraged to register at singlestore.com/managed-service-trial. You can create your own account, and we're going to work through the portal to set up today a demonstration of your own table with a shard key. So let's do that together. Let's try this on. Beyond creating your account, which we're going to work through together on setting up your cluster, we're also going to have some sample code that you can run. That sample code I'll also be sharing through this bit.ly link, which is a GitHub gist in the Zoom chat. So I'm going to now take my screen off of full screen mode, and I'm going to split the screen in half. In fact, we're going to have on the left side the presentation that you've been seeing, and on the right side, we're also going to have our portal. So what is our portal, you ask? We have a website, which is portal.singlestore.com. Once you have registered from the main managed service account, you can go to portal.singlestore.com and you'll see a view similar to the one that I'm seeing on my screen. If it's your first time signing into the portal, you may be seeing a different UI. You may be seeing a different welcome screen that's asking, are you looking to build a product on the cloud or as a self-managed product? In this case, we're going to choose cloud. You're going to create the managed service or database cluster option. If you refresh your screen, that welcome screen will go away as well, and you will see a view similar to the one on my screen. I'm going to take this to a full screen mode now so I can show everyone how we're going to create that cluster together. All right, so once you've created your account, you'll have your $500 of free credits, so not to worry, there's no need to put any credit card or anything attached to your account. I'm going to click on that Create Database Cluster button. You may see that in the middle of your screen. You may see that through the Welcome Screen UI or at the top right of your UI. So I'll click on Create Database Cluster. Once this brings us up here into the cloud, you'll have the option to create a SingleStore cluster in the managed service. For purposes of today's lab, you can keep the name as it's written, and you'll be able to choose a free trial option. That one's not available for me, so I'm going to run with proof of concept. So you can click on free trial option. You can choose a cloud provider. I'll go with AWS, and you can pick a region nearby you. So in this case, North Virginia if you're on the East Coast, Oregon if you're on the West Coast. I'll choose North Virginia, and then you can choose a cluster sizing for how much compute you'd like to work with. In fact, I can press the edit button and see these different sizes and the approximate cost per hour to work with these different storage units. For today's lab, I'll keep us with an S-00 for our sizing. And you'll notice that storage says disk unlimited because as of our newest version this summer, we now provide unlimited storage. So there's no need for you to worry about planning storage. That's chosen for you. You can focus on the amount of compute you need to solve your requests. I'll press the next button now, and now we can go through our security features for the database cluster. I'll click on the generate storage, generate passwords. I'm going to generate a strong password. I'll copy that to my clipboard, and put that in a safe location so I can use that throughout the rest of the session. And then you can configure your cluster access restrictions. Best practice is only from a specific IP, such as your IP. For the purposes of the lab, I'll just choose allow access from anywhere. Either one is fine. And I'll press create cluster. Like that, the cluster is being created in real time on AWS through the SingleStore managed service. The product is spinning up. It's going through deployment of setting up 4 different nodes if you're running with the S-0, or 2 nodes if you're running with the S-00, and installing the MemSQL and SingleStore software, and getting it all provisioned with internal communication and external communication. That process could take a couple of minutes. So while it's deploying that, I'm going to run through a knowledge check with all of our participants during this session. So I'm going to move this to the right side of the screen, and we're going to go through a knowledge check on sharding and sharding keys. Now, as I go through this process, if you have any questions, if this is too fast, you need me to repeat a process, let me know. Happy to clarify any points at all. All right, I'm going to take the screen back to full screen, and while our clusters are getting set up, let's do a knowledge check on sharding and shard keys. Then we'll work together to see how you can code in our SQL editor. So here is our final knowledge check for today. This knowledge check is asking you to determine which of the following best describes what a shard key is. You'll use the same poll EV link from before, and only one option is correct. So take a look for which one you think best describes what a shard key is. Okay, I'll give everyone another 30 seconds on this question. All right, let's reveal. I'm locking the question, and let's see your responses here. Okay, we got a few responses here, and what we see is, well, it has something to do with a column. And what does it do for that column? Looks like the majority of you got the correct answer. This is determining how the partition stores incoming data. Yes, that is the shard key. In fact, some of the other questions that we're seeing here may have been a little tricky for you, because when you look at those responses, it could be beneficial for a column store or row store or the different data structures, but we're always looking for the best response. In fact, that is option A in this question. So great participation there. All right, and this will now lead us into our final section before we go into an open discussion, which will be to code together. So let's take a look and see what's happening with our cluster and its current setup. So in this case, my cluster is almost up and running. So it looks like we'll be there in just another minute. I'm going to start talking about the navigation that we have here, if it's your first time seeing our managed service environment. So there's a few settings you have available. First and foremost, you have the overview. This will show if you're working in production, the sizing of your system, the region that you're working in, the version of the product. We have version 7.5.9, our most recent upgrade for 7.5, which came out this month. And if you have high availability on, which is protecting for data loss, you have access to see your username and password and reset that in case you forget. And there's other sections here that are very important as well, such as the firewall section. This is where you can change your inbound and outbound IPs at any time. your security section, where you can upload a CA certificate. These are secured based on TLS and SSL credentials. You can actually upload a certificate and even work with the SQL statement to use this across this cluster and any other SingleStore clusters. You can audit your cluster if you're running a lot of SQL statements with the create cluster report command. And if you want to check in on updates, you can see if we have any scheduled updates going on in the next few weeks. Currently, there's no scheduled updates. And there's a monitoring section. So when you work with SingleStore, there's several different routes you can use to access the environment. One is through any SQL IDE. Second is through the HTTP API. And lastly, through monitoring with our SQL IDE. So there's a few options for you to get started when you're working with SingleStore Managed Service. You don't have to go directly from the monitoring option. We also allow you to work directly through the query view on the left side pane. This allows you to work directly with the SQL editor that you could access for any cluster that you have. You may notice that I have multiple clusters up and running that I've been working with, and I can access all of them through the SQL editor that we'll work on together. Looks like my cluster is now successfully up and running online. There's a few other parts of the UI I'd like to share with you. There is a Connect tab. This Connect tab, if you click that, it shows different options to connect to the MySQL endpoints. So you could actually use the MySQL client or SingleStore endpoints. You could use a SQL IDE that you choose, such as SQL Pro, SQL Workbench, applications. So if you're working in different programming languages like Ruby, Python, Node, or Java, and business intelligence tools such as Looker, Tableau, Power BI, and other ones as well. So there's many ways to connect to your cluster to work with our distributed SQL. In this case, I'm going to work directly from our SQL editor. So on the left side of the screen, I'm going to press SQL editor, and then at the top of our navigation, you can choose the cluster that you want to work from. So you should have one cluster primarily, your name. That's the one I'm going to work with. And then you could also choose a database. In this case, we're starting from scratch. So in fact, you will have no code available in your screen, and you can start from scratch. The code that we're going to use is going to be what was shared on the bit.ly link. If you take a look at that bit.ly link that was shared in the chat, that will look like this in your browser. It will redirect to a GitHub gist where we have the code we'll be using for this session. So for the code that we're going to be using, there's going to be 3 different statements we'll be working with. The first is we're going to create a database. I'm going to toggle back to the SQL editor. I'm going to paste that code. So we're going to create the database. If it does not exist, DB training. And I can either highlight the code or anywhere in the code block or the end, as long as there's a semicolon, I can press Control-Enter and run that SQL command. Now everything's being done on the cloud. So this database was created on the cloud. In fact, I can now click on the drop-down navigation, and I can see that this database, DB training, is now available for me to work with, create tables, and query against. Alternatively to using that dropdown, there is the option to use the use command, in this case, use DB training. And by running that command as well, it will switch or toggle on that database as the primary one that will be running commands. All right, and our final command that we're going to run today during this Lunch and Learn is creating the table, creating your own one from scratch. The code has been provided for you, and I'm going to talk through this scenario. So the scenario we have is, well, you might be working with a fintech application. Perhaps there's an application where you have different transactions. The transactions include your paycheck, include outgoing transactions, for different payments, the balances, and you have a lot of these transactions. Some months you may have 3 or 4 transactions. Some months you may have 100 transactions, especially if you're swiping a debit card to get a cup of coffee or eat out at a restaurant or make grocery purchases. So what we have in this scenario is a table known as the balance, where you can discover what is the balance of an account based on different columns. By default in SingleStore, when you create a table, you're creating column store tables. These are tables that are highly resilient and can support both transaction and analytical workloads. And the SQL that you do write in SingleStore may look familiar to you. It is MySQL Wire Protocol compliant. In fact, SingleStore supports over 99% of MySQL SQL commands, in addition to ones that our engineering team have built in-house. So when we create a table, a lot of this could look familiar for the MySQL audience, but we have a few new things here, such as a sort key and a shard key. On SingleStore, the sort key is part of a column store, and in fact, this sort key is how the compression occurs to build a very fast system. In a future Lunch and Learn lecture series, we're going to cover more about column stores, row stores, universal storage, and how keys such as sort keys help speed up your data workloads. So for now, just take a note that this is part of the column store structure. And in addition, we have the shard key, which was just covered in part 2 of our session here today, where the shard key is chosen based on the company ID. Why would this be important? Let's think back to having a bank account and making transactions. Perhaps your transactions go to different locations. One day it's to Starbucks, another is to Dunkin' Donuts, a third is to McDonald's, and these transactions can be distributed among those companies. There could be a good chance that there is a high cardinality or a high uniqueness there. And in that case, you would choose a good shard key, and you can run Control-Enter to create this table and have it available to now start inputting data and then querying for analytics and insights. I'll show you one more way to now access this cluster, which you've set up with a few SQL commands, which is by clicking directly on the cluster and navigating to the Monitoring tab. You may recall earlier that we chose a password for your cluster. In fact, by clicking the Open SingleStore Studio button, will open the monitoring environment where your default username admin includes the password that you chose for your cluster. You can choose Submit and sign into this monitoring view where you can see the health and status of your cluster. So I can see here I have 3 nodes, a healthy database with the amount of usage and storage. And on the left, I can take a look particularly at the table I just created by toggling into the Databases tab. Under the Databases tab, I'll see the DB training database that we created together, that it has one table with a couple partitions. I can click in and then see that the balance table has been created. It is a column store table. And when I click into that balance table, I can see all the information here, such as the names of columns, the data types that were created, if there are any persistent computed columns, and memory or disk usage. If this is a newly created table, that information has not been populated yet, though this is a great monitoring view to discover more about SingleStore. We could also see on indexes, for example, the shard key that was created, it's here, so you can always recall what was that shard key for a future reference. And we see here the date ID, which is the sort key for clustered column store key as well. If you had sample data, that will be visible, and the SQL tab will show you the metadata or the original configuration for the schema of the table that was created. And then that's available here, so you can see more about if everything's as expected and what some of the smart matching that SingleStore's engine applied to fully creating that table. So that's a little bit about the SingleStore Studio monitoring environment and through the portal in the SQL editor. If your cluster's still coming up and running right now, you're welcome to code along, try out those commands that we did so you can get some of that hands-on experience. And while you're doing that, I wanted to review a few other topics about SingleStore, and then we'll open it up for an open discussion. So what you've discussed today is about distributed SQL. It's an engine that can run any request for data-intensive applications, from fast analytics to applications that are mission critical for large corporations and startups and scale-ups. In summer 2021, SingleStore launched the industry's first unified cloud database for data-intensive applications. This means SingleStore is solving for transaction workloads, which are operational, such as fast lookups and high concurrency, where you have a lot of users running requests over and over, and for analytic workloads. So you might be looking at a data warehouse where you have fast queries and a large amount of data that's being aggregated into views. SingleStore today is a single database for all workloads, and we have this through our patented universal storage technology. A few more things to know about architecture. If you're joining us today during the Lunch and Learn, you may have worked with other SQL products out there, such as MySQL, Elastic, Redis, Spark, Hive, HBase, MySQL, and Microsoft SQL Server. A lot of these products that work together often, well, they're not as fast as SingleStore alone. And so we encourage you, as you're learning from today's session, to see how SingleStore can power your data-intensive applications. You might actually find out that not only you save in speed, but also in cost as well. And with our summer 2021 release, that's 7.5, we came out with 6 critical features that have continued to have SingleStore lead best in class. The first one, security and compliance. We support HIPAA, GDPR, CCPA, encryption at rest and movement, and other world-class security features. We have a flexible pricing model where the cloud product is now charged not by the hour, but more granular by the minute. A suspend and resume feature where you can pause your cluster and bring it back online, so you're only paying for compute when you use it. The universal storage feature where your storage is unlimited and it is working for all workloads. So we have both the separation of storage and compute powered by the universal storage ecosystem. And finally, a limitless point-in-time recovery, which means when you work with SingleStore Managed Service on the cloud, you can recover your data to any point in time. And that is exciting, especially when you're working with lots of requests and changes to your data warehouses and your tables in your databases. Lastly, I'll share a couple more items and then we'll open up for discussion. If this is your beginning learning path with SingleStore, there's a lot of great opportunities to continue to learn your way. You can learn by reading at docs.singlestore.com. You can engage with your peers at singlestore.com/forum. We have a YouTube series with our developer team at youtube.com/SingleStore, where we show different product integrations, such as with Kafka and other technologies such as Python. And you can learn through training with sessions like these, also through training.singlestore.com, and learn from anonymized questions from our clients with our knowledge base, where you can see different ways to build the best solutions for SingleStore, both self-managed and managed service. We have more upcoming events that are going on this month. In fact, we have next week an event for launching a cryptocurrency exchange. If you are a fan of cryptocurrency and different blockchain technologies, we're going to be featuring Dendi Suhubdi, who is the founder of Bitwire. That will be on September 21st. You can check that out more at singlestore.com/events. And we also have this month the Google Cloud Dev Day that SingleStore is in partnership with Looker, and the AWS Dev Day as well, to see how SingleStore is better together with Looker on all of the cloud platforms, including GCP and AWS. All right, with that, this has been our Lunch and Learn in Architecture for Developers. It's an introduction or primer on distributed SQL systems. I'll now open up for any questions you may have and see how we can help you continue to scale.
Thank you so much, David. That was a really informative and interactive presentation. Really appreciate that. I do see one question in the chat box for now. And again, as David said, feel free to place your questions in the chat box or unmute yourself. But a question from Ed here: can SingleStore be used as time series data store like Influx Database?
Absolutely. So SingleStore does fully support time series applications. We support the time series data type. We support date and time data types as well. Those can be used for both workloads, those that are focusing on transactions and analytics. In fact, we have a whole section on time series data in our documentation. I'm going to drop right now into the chat, so you're welcome to dive deeper and see how SingleStore works with time series data.
Awesome. Thanks, David. I'll leave it open for another minute for questions. If anyone thinks of questions after this, David, what's the best way? Should they reach out to you, or is there a general info account they can reach out to?
Yeah, so there's a few ways they can reach out. Definitely, I'll also drop my email in the Zoom chat. So I'm at Yakobovitch@singlestore.com. You're always welcome to reach out. I can point you to any of the resources you have, and depending on those questions, glad to be helpful as well.
Awesome. Thank you, David. I see a question from Jim here. You demonstrated how structured data can be used. How does SingleStore handle unstructured data or documents?
That's a great question. SingleStore does fully support unstructured data. One of the primary ways that unstructured data is supported is through JSON, the JavaScript object notation, and those JSON objects are fully supported. We have a whole section on that as well. I'm going to share in the chat more about working with JSON on SingleStore. We support persistent computed columns. We have unique functions as well on JSON. The link I shared will get you started, and you can also see that we'll have in our docs more about all the functions to dive deeper into JSON and other unstructured data, including geospatial data.
Awesome. Thanks, David. Well, those are all the questions that I'm seeing. Once again, thank you, David. Thank you, SingleStore, for a wonderful presentation. This was recorded, will be posted right to YouTube channel and then shared to the meetup group where you registered. I encourage you to reach out to David with any questions, and please utilize those amazing $500 in credits. Thanks for everyone for being with us. We'll see you next time.